All right. So I'm not even worried about the directions up there. We're just going to talk about these and solve them. These are what form? Exponential, because it has an exponent, x is in the exponent, and also it doesn't have logs. So you're either doing logs or exponential. So the way you solve this are those three magic words. What are those three magic words? Left, right, middle. So it's in exponential form. What do I do to put it in log form? Before that, what makes it log form? Put log, yeah. What's your left? What's your right? Equals, what's your middle? Now, realize that your exponent always needs to be on the left side, okay? So all of ours are going to be set up that way, but it could be possible that it's set up opposite. Just make sure your exponent's always on the left, okay? All right, can we do this? Do we know how to evaluate this? Y'all remember from day one? But yeah, put it in the calculator. That's how you do. So remember to put it in your calculator. You go to math and up to log base. And then we have log 13 of 30. And a lot of times these numbers are not really good. You're probably going to get decimals, and that's okay. Don't stress out. All right. So go 4 decimal places to help you out. Okay. 4 decimal places. And then it doesn't matter if you round it correctly or not. Okay. So 4 decimal places will get you the right answer regardless whether you round correctly or not. So this evaluates to 1.3260 equals x plus 5. How do I solve? And you can do that straight in your calculator. So we're going to minus 5. Then we get x equals negative 3.6739. You can leave it just like that. I know that's not correct rounding. It should be 40, but that will give you the correct answer, okay? So don't stress about the rounding. Like, don't ask me about it because I'm telling you it doesn't matter. All right. Any questions on the first one? Is that hard? Not too bad, right? All right, check the next one. It's in exponential. How do I put it in log form? Yeah, make sure you write the word log. Your left is 18. Your right is 46. And your middle is b minus 2. Evaluate it. Math, log base, 18, 46. Gives me 1.3246. And then how do I solve? Add 2. You probably didn't need to do that in your calculator, but I did it anyway. I get 3.3246 equals b. Remember, we don't have to check these because exponentials are all good, okay? Logs are the ones that can cause extraneous solutions, so you don't have to check these. All right, so what's different about 3 and 4? There's another number. Just like logs, we need to get that exponent by itself, so we don't want that other number, and the other number he's talking about is this right here. We got to get rid of that. How do we get rid of it? Add 4. So you want to get rid of that first. Add 4. We get 5 to the n minus 7 equals 83. Now it's just like 1 and 2. We're going to write it in log form. So we're going to do log. Push your left, your right, and your middle. Evaluate it. Math, log base, 5, 83. Gives me 2.7456. And then how do I solve? Add the 7. Perfect. And again, you shouldn't have to do that in your calculator, but I went ahead and did it. 9.7456. That's pretty much it, guys, okay? That's pretty much it. All right. We get number 4. How do I solve number 4? Get rid of that 10. (11 to the x plus 8.8 equals, sorry, I didn't mean to put the negative. We're going to change the form. Log, push your left, right, equals x plus 8.8. Log 11 of 3 is 0.4581. How do I solve? Subtract 8.8, and I get x equals negative 8.3418. That's it. Nothing crazy. All right. So on the next one, what's different on these? There's another exponent. Does everybody see the other exponent? There are two ways to do this problem. These four have to be done the same way, but I want to show you some on your quiz that can be done a different way, okay? The reason these can't be done any other way is because I can't make the bases look the same. We'll explain it in a minute. Just trust me on that. But these are the worst problems, okay? So if you can get these and you don't think they're that bad, these are the worst, okay? Everybody got it? All right. So what you want to do, and this will work every time too, it would even work with the ones that we just did, is when we have exponential, you can log both sides. And what that means is I can just write log in front of 2 to the 3x and log in front of 12 to the x. I'm gonna do this on a separate sheet of paper so you guys can see it a little bit better. Sorry guys, I'm moving to another sheet of paper. So 2 to the 3x equals 12 to the x. We're going to log 2 to the 3x. We're going to log 12 to the x. Go back to your properties. What do your properties tell you? What can you do with those powers? Put them in front of log. We learned that yesterday. We can move them to the front. So we're going to have 3x log 2. Sorry, equals x log 12. Okay. I need the logs on the same side. Same steps every single time, okay? So log both sides, move the powers. Then to get them on the other side, we're multiplying. So to get them on the other side, we're going to divide. So your log 2's cancel out over here. You get 3x equals x times, put this in your calculator. Regular log beside the 7 key. So right here, log 12 over log 2. What do we get? When I multiply that by x, I get 3x equals 3.5849x. How do I solve this? Like if I had an equation that looked like this, how would I solve that? 2x equals x. You've been doing this for years. Subtract the 2 or subtract the x. Either one, you got to get them on the same side because they're like terms, right? All right, so I'm actually going to subtract 3, so that'll keep this one positive. Okay, so I'm going to subtract the smaller one. So subtract 3x. What does that give you on this left side? 3x minus 3x is 0. 3.5849 minus 3. .5849. Guys, don't lose yourself. It's simple math. It's algebra. It's not hard. It's just decimals. How do I finish solving for x? Divide. And I get x equals 0. Y'all, that's it. That's all you do. Okay, so don't stress out too much. We're going to do another one. Like I said, these are the worst ones. There are other ones that are like this that are a little bit easier. All right. I'll move it so you can see it in a minute. 6 to the 2x equals 25 to the 4x. What do I have to do to get those powers down? Log both sides. Then what do? Move your logs. So 2x log 6 equals 4x log 25. What do I do now? And you could divide by log 25. It doesn't matter which one you want to do. It's up to you. So this leaves me with 2x equal to 4x times. Evaluate it in your calculator. Make sure that you close that 25 up. Log 25, close your parentheses, divided by log 6. What do we get?
1.7964.
Besides your 7. Is everybody okay? How do I solve this equation? What do I have to do first? Yeah, I got to get these together. So go ahead and multiply it by 4. So we get 2x equals 7.1859x. Now what do I do? Subtract 2x. I get 0 equals 5.1859x. And then what do I do? Which is still going to give you what?
0.
Good. Will it be 0 all the time? No. These are just 0 because both of your powers right here contain like 2 times x or 4 times x. So the other one was 3 times x and 1 times x. So those will always be 0 like that. But if it's add or subtract, like the next ones, it will not be. Okay. So again, these are the crappy ones. All right, these are the crappy ones. Number 3 is 3 to the x minus 7 equals 2 to the x plus 4. Is there space on the back? Mine's blank. Okay. Sorry, mine's blank. Sorry, y'all. All right, how do I get those powers down? Yep. And I'm going to go ahead and bring them down on the next line. My power comes down because I logged 3. My power comes down because I logged 2. If you have to do it in 2 separate steps, do it. If you can do it in 1, do it. What do I do now?
Divide by the log 3.
Okay. So on this side, I'm going to have x minus 7. On the other side, x plus 4 times log 2 over log 3 is 0.6309. Now what do I do? Yep, so you kind of have to distribute. X minus 7 equals 0.6309x. You also have to multiply it by 4. You get 2.5237 plus 2.5237. Again, this is a normal equation. It's just got ugly decimals in it, so don't freak out. You know what to do. How do I solve it? You can add 7. You get x equals 0.6309x plus 9.5237. What do I do now?
Subtract the 9.
Not the 9. The 9's good. It's a single number. Yeah, we got to get our x's together. So I need to move my x. Negative 0.309x. Subtract it. So 1 minus 0.6309. 3691x equals 9.5237. Last step. Last step. Divide by what? 0.3691. Then we get x equals, sorry, that's not what it equals. Uh, 0.5237 divided by 0.3691.
25.8024.
8024. And that's it. It's just really crappy work. And again, it's because of those decimals. One more of these and then I'll try to find you some easier ones. And there's a couple fractions that I want to go over on the quiz. They're not hard. All right, so we have 7 to the 3x plus 2 equals 11 to the x minus 1. What do I do? Exponents in the front, log 7, exponent in the front, log 11. What do you do now? You can divide by log 7. So this cancels out, leaves me with 3x plus 2 equals log 11 over log 7 is 1.2322. But we got to multiply that by x minus 1. We're going to distribute. 3x plus 2 equals 1.2322x minus 1.2322. How do I solve?
Subtract 2.
So we get 3x equals 1.2322x minus 3.2322. What do we do now?
Yeah.
Move this 1, 2, 3, 2, 2x. Three minus 1.2322 gives me 1.7678x equals negative 3.2322. Last step. So divide by 1.7678. And we get
1.8283.
positive?
No.
No, negative. And that's it. Okay, those are the worst ones. And they're only bad because they have those crappy decimals, okay? It's the same work you've been doing for years. All right, so let's look at your quiz. Don't go anywhere yet, Zoomers, don't go yet. I don't know why these were not in the notes. These are always in my notes. I should have just done it myself, but here you go. Here is an easier way to do it. If you possibly can, you want to change the base, okay? So what does that mean? On this one, we have a base 5. Can I write 25 as base 5? So basically what I'm saying is, can 5 to the something give you 25? What?
2.
5 squared. So I can change this, leave this first one the same because I want it in base 5. And I can change 25 to 5 squared. This is your quiz, so make sure that you're writing this down, okay? Just like logs, if I have one log on one side and one on the other, I can mark it out, right? Same concept. If I have a 5 on one side and a 5 on the other, I can mark it out, which makes my equation so much easier to solve. There's my equation. How do I solve it?
Add 4.
Add what?
I'm gonna add 2.
Add 2 to get 4. And then divide by 2. And m equals 2. So if you look at number 4, and you look at number 3, and you look at number 5, they're already in the same base. Does everybody see that? So you just mark them out and solve the equation. Look at number 16. I'm going to go back to number 2. Don't freak out about that one yet. Look at number 16. Not 6, it's 6. Number 6. I'm looking at the, good gracious, y'all. I don't know what I'm going to do tomorrow when I don't have a day off. Is everybody good? We got it this time. All right. How can I make 16 and 64 the same base?
Square root.
No. I got to have the same base. So like base 2, base 3, base 4. Can I do 2 to the something? Can I do 3 to the something, 4 to the something, and get both of them in that category?
4 to the third.
4 to the third will give me what?
64.
What will give me 16?
4 to 4 to 6.
Yeah, so I can change this to 4 squared, but you see how I still have that power? I have to leave that power up there. 64, you said, was 4 to the third, right? I made them the same base, so I can cancel the base out. And the problem that I'm solving is 2 times 2b equals 3. Y'all, that's it. Okay, so if you can get it to look like you can, if you can't, log both sides, bring down the power, do all that work. It'll all work out the same. Okay, so if this is something that you're not understanding, do what we did in our notes, log both sides. I'm just trying to give you something a little bit quicker, okay? All right, so now I'm going to do number 8 because it has 2 fractions, so then you should be able to do number 2, okay? So what we're going to do is we're going to look at the denominator. Is there any base that I can use to cover 9 and 27? Base 3. Now it's going to be on the bottom. So what happens if it's on the bottom and I want to move it to the top? Does anybody remember what happens? Nope. You're close. I understand where you're coming from, but we're just talking about a power. So like if I had 1 over x, but I want that x on the top. I don't want a fraction anymore. Do you remember how you do that? How you get it on the top? Nope. What do you mean? Close. So what you change is actually the power. Okay. So what is this power right here? 1. So to get it to the top, we move it to the top, but we change the sign of the power to a negative. Does that make sense? All right. So I showed you that to get here. 9 is what? How can I change it? 3 squared. So what we're going to have is 1 over 3 squared to the negative x. 27 is 3 to the what?
3 to the third.
3 to the third. But I don't want to work with fractions. Okay? Y'all understand that? I don't want to work with fractions. You don't either. I know you don't. So we're going to take these and put them to the top. So how did I tell you to put them to the top? So instead of 3 squared, it's going to be 3 to the negative 2. But I already had a power of negative x. Does everybody get that? So on the other one, what's it going to be? Perfect. That's all you do to change them. Now they're in the same base. So what can I do to those bases? And I'm going to solve 2 times negative 2 times negative x is 2x. Negative 3 times negative 2x is?
Six X,
This is like the beginning of our homework. How do I solve this?
maybe.
I'm going to subtract the 2. Doesn't matter which one you subtract. I get 0 equals 4x. How do I solve? And I get x equals.
Zero.
That's it, y'all. That's all you do. So the hard part is looking at that fraction and fixing it. All right, so when we look at number 2, I'm going to go back up to number 2. Can I write 6 and 216 as the same base? If you don't think you can, you just log both sides, bring the power down, do all that hard work. What can I write 216 as? Can I write 6 as any other base at all? No. So what do you think the base could possibly be? 6. So try 6. 6 to the third. Is everybody good? So this one, remember, is 6 to the 1. We're going to change this to 6 to the third, but don't forget you have 3 minus 3b. So how do I fix this 1 over 6? And what's it going to be?
6 to negative 1.
Times equals 6 to the third times 3 minus 3b. Now your 6's cancel out, and there's your equation. Make sure you distribute that 3 in the second one. Does everybody get it? Y'all okay with those fractions? Those are the only ones I worried about. Let's look. Same thing on 9 and 10. Try to find the same base, and it will cancel itself out. So on 9 and 10, if you'll find the same base, you'll be fine. And then 19 and 20, you cannot find the same base. Okay, so 19 and 20 are the only ones that you have to do like our last 4 problems where they were really, really long. Is everybody good? Everything else should be fairly easy. How do I do 11 through 18? Before left, right, middle, what do I do though? I gotta make sure, yeah, get that exponent by itself. So on this one, what am I gonna do to get the exponent by itself? You might wanna write that down. Subtract 10. What am I gonna do on this one?
Divide by 4.
You have to divide by 4 because I'm multiplying 4. Okay, divide 4. Same thing on this one. What do I gotta do? Divide by 3. This one?
Divide by 8.
What about this one?
Divide by negative 1.
I can divide by -1, and that would be fine. Do you have to?
No.
No, you don't have to. What about this one? Add 4. What about this one? What about this one? Divide by -8. Is everybody good? So do those steps before you log left, right, middle. Any questions? All right, I'm gonna stop sharing, stop recording.